Thank you so much for joining this lesson. We're going to discuss physics paper 2, the X-ray tube and the production of X-rays. The question says the figure below shows the features of an X-ray tube. Study it and answer the questions that follow. So we're going to study the diagram, then we answer the questions that follow. Let me start by saying that the first part here, you can see X. This one is a step-up transformer. A step-up transformer. This one is purposely to ensure that voltage is stepped up, so that, because as you can see, there is the anode here, which is connected to the negative. The anode is connected to the positive terminal, sorry. Then the cathode is generally connected to the negative terminal. So now the step-up transformer is to usually boost voltage, so that there usually exists a very great potential difference between the anode and the cathode. This is to ensure that produced electrons are accelerated towards the target here, the target which is attached to the anode. Therefore, briefly to mention about the production of the X-rays, it is that, remember there is this is a rheostat, or simply a variable resistor. It can even be a potentiometer. This resistor is to ensure that current is controlled to the concave cathode. This one is the cathode. Now, the metallic cathode is usually heated up by the electrical method, and once heated up, the electrons on its surface get excited, they gain kinetic energy, and eventually get emitted from the surface. They get emitted, you can also say they get dislodged from the metal surface of the cathode, and once they have been emitted from the surface, now they are usually accelerated by the great potential difference towards the target. On hitting the hard target, mostly made of tungsten or a material called molybdenum, they now have their energy, the energy of the electrons, which was kinetic, getting converted into heat energy, and part of it, a smaller percentage of course, now becomes the X-ray. So D is the X-rays. So the X-rays are produced when electrons, this is a beam of electrons, a fast moving beam of electrons is suddenly stopped by the metal target on the other side. Then now we can now study the questions now, the specific questions according to the examiner in this question. State and explain which material is suitable for part C. So part C is the metal target, which is on the anode. This metal target is usually made of tungsten. I've said an alternative can be molybdenum. So these are metals with a high melting point. They have a high melting point to withstand the great heat. To withstand the great heat energy at the anode. To withstand the great heat at the anode. Remember, we've said the kinetic energy of the electrons is converted into heat energy with a small percentage becoming X-rays. Therefore, the great heat requires a very hard, not even hard, a material with a very high melting point so that it doesn't melt quickly. Why is part B made of thick copper metal? Part B is the anode. This one is the anode. We actually call it the copper anode. It's made of thick copper to ensure that the heat is effectively dissipated. So to dissipate is to transmit away, dissipated from the anode. This is because copper is a good thermal conductor. So we can even actually start by saying that copper is a good thermal conductor. So copper, being a good thermal conductor, ensures that the heat produced at the anode is effectively dissipated away immediately it's being produced during the operation of this X-ray tube. Explain why the machine should be surrounded by G. Explain why the machine should be surrounded by G. So G is called the lead shield. So G is a shielding of the X-ray tube made of lead. So G is first of all lead material, the lead shield. So we say that lead has a high density. Lead has a high density to ensure that stray X-rays are absorbed. And this is to protect or protecting the person operating, the operator of the machine here. So the person operating this machine is going to be safeguarded because lead is a material of high density. Remember, X-rays have a penetration power, but they can be stopped. They can penetrate very many substances, very many materials, but they get stopped by thick lead. Therefore, lead will stop any beam of X-rays which is not produced through the window. This one is the window. So if X-rays are not directly going through the window, it means they are stray. They are going to undesired angles. And those X-rays going to undesired angles, since they are harmful to the human skin or to the human body, to the body cells, then they have to be taken care of. And that is why we have a lead shielding to absorb them. A different material with a lesser density will allow their penetration and it will cause damage to the operator of the machine. State a reason why H is concave. We had talked about H during the production of X-rays. This is the cathode. This cathode is usually concave to ensure that the produced electrons are accurately focused to the target. So this is to focus or to direct. To focus, to concentrate, or even to converge. The beam of electrons at the target or even at the anode. So without it being concave, they will still be attracted but not effectively. So for them to be well attracted, you can see they are having a convergence motion. So they have to be converged at some point. That is because, remember, it's a wave. So they have to be converged at a point, and that is ensured by the cathode being concave. If it was plain, they would still go, but they would not be focused at one point. During the operation of the tube, the target becomes very hot. Explain how this heat is caused. This heat is caused by, we have said that the energy which is kinetic in this case. So the kinetic energy of the electrons, of the moving electrons, the kinetic energy of the electrons is converted at the anode or at the target to X-rays. This is a small percentage, around 0.5% of the energy, and the bigger percentage, which is heat energy now, and heat energy, this is 99.5%. So with such a percentage becoming heat energy, then the target has to become very hot. So it becomes very hot because the energy in the electrons is converted into X-rays, 0.5 percentage, and 99.5% approximately becomes heat energy. So with that, then the target has to become very hot. We have part F. What effect will increasing current at F have on X-rays produced? So let's go back to the diagram and we see what F is. So we are asked, increasing the current at F, that is the ether filament. F is the heating filament or the ether filament. Now we are asked, if current is increased there, what effect will it have on the produced X-rays? And simply, we will say that the intensity of the X-rays is increased. That is the effect. The intensity of the X-rays is increased. The intensity is increased, or more X-rays are produced. This is because we are heating. Therefore, the thermionic effect is increased. Therefore, this is because the current increases the heating effect. The heating effect, that is when it increased. The current increases the heating effect, leading to production of more electrons and hence more X-rays. Remember, it is the electrons which will be converted into X-rays. Therefore, the greater they will be, then the more dense the X-rays which will be produced. Let's go to part F, or part G, sorry, after F. Part G is asking us, what effect will increasing potential difference at B have on the X-rays produced? Potential difference at B. So when the B is the anode, so when potential difference at B is increased, the electrons will be greatly accelerated towards the anode, which means they will come with a greater speed and hence a greater kinetic energy they will possess. That means the X-rays produced now will be having a greater energy. Those can be called odd X-rays. So we are saying that the effect of increasing potential difference is that high energy X-rays, which can be penetration power, it's the penetration power, which can also lead to high frequency of the X-rays. X-rays are produced. That is the effect that will be caused by increasing potential difference. This is because increasing potential difference will lead to increased acceleration of the electrons towards the anode, which increases their speed and hence kinetic energy, which increases their speed and hence kinetic energy, leading to high energy X-rays. In this case, we are calling them hard X-rays. So hard X-rays are going to eventually be produced because electrons are strongly attracted, which means they go there with a great speed, which means they are possessing a greater kinetic energy. It is that great kinetic energy which gets converted into X-rays. So electrons are attracted with a greater attraction, which means they will land with a greater speed. State two ways in which cooling is achieved in this X-ray machine. So cooling in the X-ray machine, remember cooling is necessary because we have said a great heat energy is produced at the anode. So to curb that great heat, we have already talked about the anode is made of thick copper that is. The anode itself is made of thick copper. Remember, copper is a good conductor to conduct the heat away, conduct the heat energy away. There is also presence of cooling copper fins, part A. These are cooling fins. So cooling fins, which are also made of copper. So presence of cooling copper fins. They also transmit heat energy away. There is also oil circulation. There is oil circulation. So these are the three mechanisms of achieving cooling at the X-ray tube, specifically at the anode. The anode itself made of copper. Copper is a good conductor, and so it easily conducts it away. There is the presence of cooling copper fins. So those copper fins increase the surface area for cooling. Then there is also oil circulation, whereby, as you can see, we've said these are cooling copper fins. We have the oil circulation. So oil comes in, and as it goes out, it will be very hot. Therefore, it will have carried away some of the heat energy. Again, there is why would it be necessary for the target to rotate during the operation of this machine? Actually, the modern X-ray tubes are made with a rotating target. This is to ensure that wear and tear are minimized. So this is to minimize wear and tear. To minimize wear and tear. Remember, changing the point of target will reduce wear and tear, unlike one which is not rotating, whereby the heating point is only one. State the order of energy changes that occur in the tube during X-ray production. So during X-ray production, we talked about thermionic emission, the first process, whereby electric current is heating a metal surface, then electrons get emitted from that surface. And now when they get emitted, they get attracted, which means they move with a kinetic energy, and it is that kinetic energy which gets converted into X-rays, and again heat energy. Therefore, we are talking about initially we have electrical energy. This is from the current. This electrical energy becomes heat energy. This becomes heat energy at the cathode. Then now that heat energy heats up electrons. They get attracted, which means they move with kinetic energy. Kinetic energy. But when they arrive at the anode now, the kinetic energy of the electrons is now converted into X-rays, and this one should be plus now, heat energy. X-rays and the other percentage heat energy. So in the last arrow, a student can also say electrical energy, heat energy, kinetic energy. Then this kinetic energy now is becoming X-rays, and the other percentage is becoming what we are calling heat energy again. Therefore, the last arrow can be handled in such a manner.